Okay, so for this one is you're gonna solve equations with variable on both sides, okay? So over here, like I said, my first step, when I see that equation, the equal side, I'm gonna draw that line. So I know this is the left side, this is the right side. It's important for me to know if my like terms on the same side on the opposite side of the line. So I look over here, the x values, this one has the x values. They are like term. I want to combine them. But if you look over here, the 5x and the negative 3x is on the opposite. One is on the left, one is on the right. So to put them together, I'm going to do the opposite. So this is negative 3. I'm going to do plus 3. Okay. This gives me 2x plus 3 equal to negative 13. Then when I look at this line, look, this is the number 3, this is negative 13. Well, again, they're on the opposite side. So what I would do, I'm doing the opposite, but it doesn't make sense for me to move the 13 because I have nothing on that side. So over here, I want to solve for x, so I would move 3 over 2x equal to negative 13. Sorry, there's no x right here. So negative 13 minus 3, I just do exactly what I see if you put in your calculator. Negative 13 minus 3 give you negative 16. To solve this one is the opposite operation, so I will divide by 2. Negative 8. Okay? So that's what I...
Oh, I have a question.
Yes.
Why did you put 5 minus 3x when it's supposed to be 5x plus 3x?
Oh, I don't know why. Thank you. Let me fix that. I make a mistake on that one then. So it's plus, this give me 8, right? Yes, thank you. So now it's ax, I divide by 8. So divide by 8, so my answer should be negative 2. Perfect, thank you. Someone pay attention, thank you. So this one, yes, this is plus 3. There should be plus 3 on both sides. Sorry, I apologize about my handwriting as well. It's really hard to write on the iPad and not using my pen. Okay, so I'm going to do another example on this side, which is a little bit, for some of us, it's a little bit intimidating because it's involved with fraction. It's worked out the same way. I will draw this line, right? Okay. When I look at this problem, I'm going to highlight all of the like term, right? Highlight all the y. So over here, if this 3 over 2y and minus 1y, I can combine that first. But it's be easier because I see 3 over 2 and 1 over 2 has a common denominator, so I want to combine those two first. So what I would do is, I'm going to move the 1 over 2y over, right? It's on the opposite side, I'm doing the opposite operation. So it's a plus half, I'm going to minus. So when I do this, 3 minus 1 give me 2. I keep the denominator. This cancel out. When I have this one, it's the same as 1 in the front. Okay. Now over here, 2 over 2, if I simplify, it's the same as 1y minus 1y equal 4. What happened when a 1y minus y? So everything cancel out. So you have a 0 right here. So look at this answer. It's strange, right? It's possible. I have a lot of students like, what do I do? It's possible that the variable cancel out. When it's canceled out, look at this statement. Ask yourself, 0 cannot be equal to 4. So what it's saying is this is a false statement. When you have a false statement, you have 0 real solution. Because it's not true, 0 is not equal to 4. So when you solve an equation and all of your variable cancel out, and the statement is not true, then you have 0 solution. Okay? Questions for me? So this is a special case. But the practice that I'm going to have you practice on is just to solve equation that when you have variable on both sides. Okay. I also I'm going to add more time to the other assignment if you did not finish. So when you go and do this one, it can be as example B. There should be assignment pop up and say example B in CUDA work. So let me stop sharing this. If you need to jot this down, let me know. But I will share this, upload this for you as well. Okay. All right.